Hello, PreCalc. You're looking at this on Tuesday after the Tuesday class, and that will be the last day of January, January 31st. We are picking up where our videos ended yesterday, and we were talking about the hyperbola. And we found that the standard form is going to be similar to the ellipse except for the sign in between. So let me review what the standard form was for the the hyperbola. It is x minus h quantity squared minus y minus k quantity squared, and that x minus h is over a squared and the y minus k is over b squared. In this case, the way you can tell whether it's horizontal or vertical is you want to see which term has the positive in it. So here we have this negative sign, and it's followed by the y term. So that means the x term is in the positive term. So I'll call this the negative term because of that negative sign, and I'll call this the positive term. And whichever term is positive, that will indicate whether it's horizontal or vertical. So when x is positive, this is the horizontal. So horizontal and then vertical, standard form, would be when we have the y term is positive and the x term is negative. Alright, so that's how we tell. So we're going to look for the positive one. Look for the positive term. Look for the positive term, and that tells you if it's x, it's horizontal, and if it's y, it's vertical. Alright, so let's see. We'll kind of leave that up there in our thoughts. And if my head's in the way, you won't have it written down. So let's go ahead and look at the problem. Here's a typical problem. You know that you have a hyperbola when it has an x squared term and a y squared term, and that x squared term and y squared term have different coefficients. So here's a 9 and an unwritten 1. So with that, we will go ahead and do this one. Let's begin like we normally do. Gather your x squared terms together. Leave a space. Gather your y squared terms together. Alright, and take your constant to the other side. Notice that this plus sign might confuse you, but put your two hands down because it is correct. Because of this negative sign. We're expecting to have a negative sign in standard form, so therefore I want this to be negative, and this value is negative, but the y term that goes with it and behind it is negative, so I have to indicate it in this form with a positive because this negative applies to it. Alright, now we go in, and we cannot complete the square just yet until the lead coefficient here is a 1. So to make it a 1, I pull out a 9. We call it factoring out a 9. And then, and only then, can we complete the square. So now the lead coefficient is 1. Over here, the lead coefficient is already 1. I don't have to factor it any further. So now what do I add? What's the special number here to complete the square? Half of this squared is going to be a 4. And so I add, you would think I would add a 4, but this is just masquerading as a 4. Really, it's a 9 times 4. So I have to remember that and add a 36. Now, in here, half of 6 is 3, squared is 9, and recognize that it was really a minus 9, so I have to subtract 9 on the other side. Alright, so what is minus 18 minus 9 plus 36? I believe it's 9. Let me see what I got. Alright, I got 9. So let's go across. I've got a 9. And what's the perfect square that's been created? X minus 2, quantity squared. What's the perfect square created here? Y plus 3, quantity squared. And we end up with a 9. Alright, in standard form, that's one thing I forgot here. I kind of left my standard form without its crowning glory here. It equals 1. Sorry about that. So go back and add equals 1, of course. So this does not equal 1, so I'm going to divide each term by 9 to create the 1 that I need right there. And this 9 and that 9 will reduce to 1, so I won't need to write that. This 9 remains in the problem, and we get a 1. So, according to our thought clouds earlier, is this a horizontal hyperbola or a vertical hyperbola? Well, I said if the x term was positive, the x term is positive, it's horizontal. If the y term is positive, it's vertical. You can see that it's the x term that is positive, meaning that the x term would be not behind this negative sign. So this is indeed a horizontal. So I'm going to sketch a horizontal hyperbola. So I'm expecting it to open and close, open to the right and left. So that's what I mean by horizontal. So I'm going to go over here and graph it. I need to do some preliminary work, but before I do that, I will go ahead and find the center. Hector and Kyle, like normal, tell me where the center is. It's at 2 minus 3. Opposite of the x, opposite to the number connecting to the x, opposite of the number connecting to the y. When it's in standard form, 2 minus 3. So I can find that right away. 2 over, minus 3 down. That is the center. It's not on the hyperbola, but it'll help us find the hyperbola. I'm going to graph this one quite a bit differently than you've seen me graph any of the others. So hold on to your seat. It's going to get a little bumpy. Alright, what we're going to do now is a sissy chart. And that sissy chart will get us through. So I'm going to go ahead, move here so you can see a sissy chart. And what I'm going to do is I'm going to take a value, and that value is going to be 0 for x, and then I'm going to calculate y, and then I'm going to zero out y and calculate x. So that's the only 2 points I need on my sissy chart. But I'm not going to throw it into the original, and I'm not going to throw it into standard form here. So what I am going to throw it into is a close cousin of standard form. And that close cousin is I'm going to remove Hector and remove Kyle. Woo! Alright, so after you remove Hector and Kyle, you have a close cousin to our problem, but it's all we're going to need to get the part that I'm looking for. And what I'm going to do is I'm going to put a 0 into this equation and solve it for y. So when I do that, I put a 0 here, then this equation is gone. I mean, this part of the equation is gone. It zeroes out. It leaves minus y squared over 9 equals 1. So I'll work on that right here. Minus y squared over 9 equals 1. So I'm going to multiply both sides by minus 9. So then I get y squared equals minus 9. And I'm going to take the square root of both sides. When I do that, I am taking the square root of a negative number, but I'm going to ignore that for a second. And I'm going to get y equals 3i. Remember, the square root of a negative 1 becomes an I. So a negative 9 is like 9 times negative 1. So I have 3i. So that's weird, but I'll deal with that in a second. Alright, let's do the same thing now. back to the close cousin. I'm going to zero out y this time, so the y disappears, and it leaves me x squared equals 1. Solve that by taking the square root of both sides, and I get the square root of 1, which is plus or minus 1. Oh, I forgot. This is plus or minus 3i. When you take the square root of both sides, you have two answers. So I get a plus and a minus 1. So, these values, obviously this value is real. This value is imaginary. So this value will not really appear on my hyperbola, but it's going to help us get what I call the box. So, from here, from the center, I'm going to go x and y plus or minus 1. I'm going to go that way plus negative 1 and that way positive 1. So I'm going to go over here 1. Where was I here? This is 2 over and minus 3 down. So I'm going to go over 2. So that puts me here. That's not on the hyperbola, but I need that point. Where did I get it? It's from my sissy chart. It tells me plus or minus 1. So I'm going to go from the center plus or minus 1. 1 this way. Wait a minute, if this is at 2, it doesn't come all the way over here. Sorry. Alright, so it's going to come over here and this way. I'll move this out of the way. Right here. So do you see from the center I went 1, 1, indicated by this. Now I'm going to go another direction in the y direction, plus 3 and minus 3, ignoring the I. So from here I'm going to go 1, 2, 3, and down 1. Where was I? 2 over 3 down, right. 1, 2, 3, right here. Alright, those 4 spots that I just added around the center are the sides, so the midpoints of the side of a box, a rectangle, and it looks like this. Alright, so you may say, what in the world does a rectangle have to do with a hyperbola? Well, it turns out that the diagonals of that rectangle are the asymptotes that we need, the fence posts, to keep our hyperbola in line. So we're going to go down like this and like this. Alright, hopefully you can draw a little straighter than I can. So our work is done. The question remains, will the hyperbola be like this, opening to the left and right, or like this, opening up and down? Well, I already answered that question when I mentioned that this was a horizontal and it would be opening left and right. Another way I can tell is these are real points. So they're actually on the hyperbola. We're at this point and this point. These are imaginary points. They just help us get the asymptotes. So I'm going to draw in the hyperbola. Alright, so that is how we do this. It's a little different. Let's recap. Take the equation, get it into standard form. Hector and Kai will tell you the center. Notice the center is not on the hyperbola. It's where the two asymptotes intersect. From that center point, I'm going to do a sissy chart, zeroing out x and then zeroing out y. One of these results is going to involve the square root of a negative number. It will have an I, plus or minus, and the other one will not. So from your center, whatever x value is, go left and right. Whatever the y value is, go up and down. Then you choose which way the hyperbola goes, horizontally, opening left and right, vertically, opening up or down, according to either, you can look at your sissy chart and go to the real number, that will help you, or you can look at the original equation in standard form, which is it, horizontal or vertical, depending on whether you have a positive x or y. We had a positive x, so we knew it opened left and right. Alright, so much for that. We will be practicing those tomorrow. Can't wait. Till then, over and out.